Okay guys, in this video lesson we're going to jump into our next unit, which is kind of a shift away from the mechanical world and the thermal world and into more about the electronic world. Okay, so we're diving into protons, neutrons, electrons, we're diving into electricity, we're diving into movement of charge and that kind of stuff. Okay, the name of our unit is electrostatics and electric forces because there is forces involved here, but they're just a little bit different. And here we go. So first of all, this term electrostatics, what does that mean to us? Okay, well, if we break the word down, we have electro, which means we're going to be studying the electric charge, and statics means not moving. Okay, so the beginning part of this unit, we're going to focus on protons and electrons and where the charge exists. We're not going to be sending it down wires and powering things yet, okay? So right now we're talking about just what is charge, what are the forces here, and we're going to get in the background or the static part of this right now, okay? This is first observed by the ancient Greeks, as they are kind of accredited for doing this first idea of what electricity is. Now, for us to do this, we want to make sure that we have a quick review of protons versus electrons, okay? So let's go down this idea. Electrons versus protons. Electrons, much less than a proton is. If you take a look, it's about 1,000 times less massive than a proton. It's also in the electron cloud versus being in the nucleus, which means being so light, incredibly light, even in the subatomic world, and because it's in a cloud and it's moving and can be exposed to external things, it's much easier to mobilize. So it's really easy for us to steal electrons off of atoms and deposit them on other things, okay? Not even like in chemical reactions, talking about like physical scraping of electrons off of things and depositing it on different places, okay? Protons, much harder to do that because they're locked inside that nucleus, okay? So what we're gonna normally do here is look at this through the lens of where are the electrons, because these are the things that we're actually moving around and shifting, right? Now, we identify their charge as being a -1 charge for an electron and a +1 charge for a proton. But the question becomes, what is charge? Okay? Most of us just kind of accept it. Oh, it's just charge. Yeah, that's a -1 charge, it's a +1 charge. But what is charge? Okay? So one of our goals in this unit is to identify, well, what actually is charge and how does that play a role with our electronics? Okay? So first of all, let's kind of get some basics behind what charge is, okay? Charge is another fundamental property of matter, all right? It is just a part of what these particles have to them. It creates forces, so it creates attractive forces and repulsive forces because of their charge, okay? Now, coming back from Benjamin Franklin, he identified that different particles have different repulsive or attractive forces, and he called that charge when it came to your protons and electrons. If they're positive, we've identified that with being a proton, okay? If it's negative, we've identified that with being an electron, all right? The positive negative was actually arbitrarily chosen by him in terms of which one we call positive, which one we call negative, because really it's just opposing forces here that we're talking about, okay? By doing this, we're saying a single proton, we gave it a single number, saying it's one positive charge. One electron, we said, is one negative charge. Okay, that way, every time we have an electron, we also can have a single digit or a single one being moved around, which is kind of nice. Now, continuing this idea of electric charge, if you take a look at a neutral atom or a neutral example of a bunch of atoms together, or a neutral system of anything really, you're looking at this idea of if you have the same number of protons and the same number of electrons on the same space, you get a neutral substance. Okay? At the atomic level, we could take one atom of, let's say, carbon. Okay? One atom of carbon, it has 6 protons in it, it has 6 electrons in it, it's a neutral atom of carbon. Okay? Now, if we were to steal an electron from that, we'd have 6 protons and we'd have only 5 electrons. So we would create positive charge on that atom. All right? We can actually expand that to the macroscopic world. We actually can take an entire body, like ourselves, or your car, or a baseball bat, or you name it, a balloon, and the entire thing, we can give it extra protons or extra electrons and move those around. Now, we usually move electrons around, and we create charge imbalance that way, okay? So don't look at this just through the lens of single individual atoms, but think about macroscopic objects that we can actually strip electrons away from them and actually give them extra electrons. When we do that, we can create positive charge or negative charge. When we get positive charge, that means somehow we've removed electrons and our ratio of protons to electrons now favors a proton, which means their electrons have gone away and you have more protons than we do electrons. If we have negative charge, that means somehow we've added electrons to our object. Okay, we're actually going to do this in class. We're actually going to take objects and we're going to give them extra electrons and kind of see how they respond to doing that. Okay, in terms of big macroscopic things. So when we give extra electrons to things, we have more electrons than protons, so now we have negative charge. Okay.